Okay, question 13. We have a nice 10-mark calculus problem. So, a company is designing a logo. The logo is a circle of radius 4 inches with an inscribed rectangle. The rectangle must be as large as possible. The company models the logo on an XY plane as shown in the diagram. We want to use calculus to find the maximum area of the rectangle. Fully justify our answer, 10 marks, so they don't really give us any clues as to where to go. Hopefully you can make the link between calculus and maximizing to deduce that there is differentiating to be done. So let's start with what we know. So the equation of the circle it's centered at the origin, so 0, 0, the radius is 4, so the equation is x squared and y squared is equal to 4 squared, which is 16. Okay, so we know that. Now we also know that circles are incredibly symmetrical, and a circle centered at the origin is going to have mirrored coordinates. So if we take this point to be x, y, the point down below is x minus y. Now what that tells us is that the height of the rectangle is 2y. So let's just put that here. And then very similarly, for the width or the length, we know this point over here is going to be minus x, y. So the length of our rectangle is 2x. So the area of the rectangle is 2x times 2y, which is going to be 4xy. Now it's that we want to maximize. Okay, so what we're going to need to do is differentiate the expression for the area. Now, we could use implicit differentiation, so that would work, and that is actually how I did this problem myself. The problem is, we're also going to need to find the second derivative, so we don't really want to be doing that using implicit differentiation, because really, when do we ever want to be using implicit? So, what we can do then is use the equation of the circle to get an expression for one of the letters in terms of the other, and then we can substitute that into the area, which will then give us an expression for the area in terms of one variable. So, we know that x squared and y squared is equal to 16, so y squared is 16 minus x squared, so y is the square root of 16 minus x squared. So now we can write A as 4x times 16 minus x squared to the power of 1/2. Okay, so now we need to differentiate that because for a maximum area, dA by dx will equal 0. So, we are using the product rule and chain rule at the same time. How exciting! So, dA by dx. Well, if we first of all differentiate 4x, we get 4 times 16 minus x squared to the power of 1/2, and then we're going to differentiate the bracket. So we are going to add 4x times, okay, well, the bracket itself is going to differentiate to, well, the bracket is now going to be to the power of minus 1/2, and 1/2 is going to come and sit on the outside. Now the inside is still going to be 16 minus x squared, but we also put the derivative of that on the outside. So we're going to get times minus 2x times times 1/2, lots of the bracket. So that gives us 4 lots of 16 minus x squared to the power of 1/2. Now we got 4x times minus 2x, which is minus 8x squared times 1/2. So that's going to give us minus 4x squared times 16 minus x squared to the minus 1/2. Now let's write that back in terms of square roots. So this is 4 root 16 minus x squared minus 4x squared over square root 16 minus x squared. Now, if we set that equal to 0, we can start solving for x. So, if we multiply through by root 16 minus x squared, we're going to get 4 lots of 16 minus x squared. So we multiplied that root by the same root. The roots become a power of 1. We get that minus 4x squared is equal to 0. So if we add 4x squared and divide by 4, we get 16 minus x squared is equal to x squared. Add the x squared, we know that 16 is equal to 2x squared. 8 is equal to 1x squared. So x is equal to root 8. Okay, so now that we know what x is, we can find y. Remember, we know from the circle, x squared add y squared is equal to 16. If x is root 8, root 8 squared is 8. So we get 8 add y squared is equal to 16. Y squared then is equal to 8. So y is also equal to root 8. So up to here then we know that x is equal to y is equal to root 8. So from this we can now work out the area that we would get. So when x is equal to y is equal to root 8, we know the area is 4 root 8 root 8, which would give us 32. So that potentially is our maximum area of the rectangle, which would actually be a square because the sides are the same. Now what we need to do is prove that this is a maximum. Okay, so to prove that we have found a maximum, we need to think about what that would mean. So if we have a maximum, then our second derivative, d squared a over dx squared, if we have a maximum, that will be less than 0. So we need to differentiate this again. Aren't we lucky? So we can do this. D squared a by dx squared is going to be. So for the first term, we only need to use the chain rule. So we're going to get 4 times a half times the derivative of the stuff in the bracket. So times minus 2x times the bracket to the power of minus a half Okay, and then for the second bit, we got the product rule and the chain rule again. So we're going to get minus 8x times 16 minus x squared to the power of minus a half. And then we're going to get, minus 4x squared times, now the power of minus a half comes down, and we multiply by the derivative from the inside of the bracket, so minus 2x times the bracket to the power of minus 3 halves. Lovely. Right. You could also have carried out a gradient test that probably would have been the nicer route, but it's good to practice these things. So, what I'll do, when we've finished off this method, I will also show you how we could have used a gradient test. So, our second derivative is going to become, so 4 times a half is 2 times minus 2x. It's going to give us minus 4x times 16 minus x squared to the minus a half. Then we got minus 8x times 16 minus x squared to the power of minus a half. And then we got minus 4x squared times minus a half is positive 2x squared. But then we got 2x squared times minus 2x. So that's going to give us minus 4x cubed times 16 minus x squared to the minus 3 over 2. Now our first two terms are both to do with 16 minus x squared to the minus 1 half. So we can simplify that to minus 12x. Now times 16 minus x squared to the minus a half means over square root 16 minus x squared. And our last term is minus 4x cubed over 16 minus x squared square rooted. So 16 minus x squared square rooted and cubed. Now, what we can see at this point is that d squared a by dx squared is always going to be negative, because both terms have a minus sign, so it's always going to be negative when x is greater than, what is that? When x is greater than 0, therefore x equals root 8 does lead to a maximum. So 32 is the maximum area. Okay, so what we'll do now, we will also have a look at how we could have shown that with a gradient test. Okay, so using a gradient test, remember that the derivative is the gradient of the curve. Then we know that, let's set up a little table. So let's have values of x going across the top. Let's have values of dA by dx going along there, and then we'll have what that means in terms of the gradient. Okay, so we know that x equals 2 root 2 is a stationary point. So we know that when x is 2 root 2, the a by dx is equal to 0. So there is no gradient. Now, 2 root 2 is roughly 2.8. So if we try a value of x directly to the left, say 2.7, then we substitute that into our derivative, and if you do that to one decimal place, I get 1.9. So that is a positive gradient. So that means so far we got this picture where the curve is coming up, then there's no gradient. Let's see what's happening on the right. So let's try 2.9 for x. Now if you put that into the a by dx, I get minus 1.9. So we have a negative gradient. So that's then gonna look like that. So we should then say just to the left of the stationary point, we have positive gradient, and just to the right we have negative. Therefore, we have a maximum at x equals 2 root 2. There we go, guys. Nice question. Done. Thank God.